Hi students, in investment appraisal, let me show you a special case. Look at this example here, 0, 1, 2, 3, 4, 5. The cash flow, let's say you invested 80,000 and then every year you were earning, let's say 22,000. Every year, same figure, every year you got cash. And that's what makes it special. You have same cash flow every year without a break, starting from first year to the fifth year. It can end at any point. It can be 5 years, 6 years, 7 years, 2 years, or whatever. Starts at first year without a break. It continues same cash flow. Can you see? Usually, investment appraisal questions we did, it was not the same cash flow. So here, what do we do? Usually, we take the discounting factor, find the present value, add them together to find NPV. Suppose let's say this is 10%. If I'm using the table figures 10%. Yeah. These are the figures I have, right? Oh, can't copy them. It's okay. First one is 909,736. So that must be 909.736. No, I'm using a wrong table. Wait. Present value factor is here. Okay, 909,826. 0.826 and then 826,751,683 and 621. Present values will be cash flow multiplied by discounting factor, add them together, that's the NPV. But see, I will give you a shortcut to get this figure. What figure? The sum of these 5 figures. How much has it been here? The sum of all these. Let's check. Which is 83,380. We have a shortcut for this. Look at this. Sum of PV of future cash flows will be that 22,000 multiplied by cumulative PV factor. Cumulative PV factor. What's the meaning of cumulative PV factor? I'll show you. Look at this. 22,000 is the annual amount. Cumulative PV factor. Go to the table. Don't use this table. There is another table. Look at here. Cumulative present value table. Can you see here? Right. We are 10% 5 year because the cash flow continues for 5 years. Look at the figure we have 3.791. 10% 5 years. Use that here into 3.791. See 83,402. Here we got 83,380. Small difference is there. That is because of rounding off error. That's okay. That difference is acceptable. Then NPV will be that 83,402 minus the investment of 80,000, which is 3,402. Small difference is there. So if you have the same cash flow continues for 5 years or whatever the number of years, starting from year 1, mind you, it has to start from year 1, then you don't have to do it one by one. You can take the cumulative PV factor and do it. Let me see another example. Let's say this is 10,000 each year, and let's say 12% is the discounting factor. Shall we write NPV at once? NPV has to be this 10,000, that's the annual cash flow, multiplied by 12% 4 years factor, cumulative factor, 12% 4 years, you have 3.307 here, 3.037. That's the PV of all those 4 cash flows minus 30,000 the investment. What's the answer we get? 370. Understand? So like you can save a lot of time by doing like this. Let's see another example. They have given this figure. There was this question in the mock exam where they have put minus 50,000 as the investment, and then cash flow 8060 every year. For how many years? For 8 years. Right. What are we going to do for this? They asked us to find IRR. So they have not given a rate. Suppose if IRR, you know what do we know about IRR? At when cost of capital is equal to IRR, NPV has to be 0. We studied that. That's the definition of IRR we studied. NPV 0 means PV of future cash flows minus investment must be 0. PV of future cash flows means what? 8060 multiplied by cumulative PV factor minus investment 50,000 is 0. So solving this, you can find cumulative PV factor is 50,000 divided by 8060. What's the answer you get for that? 50,000, 6.203. Now what you do, you know it's 8 years, but I don't know the rate. We'll go to the table. This is cumulative factor. 8 years table. See where you have 6.203. Did I read the question correctly? 8060 for 8 years. Yes. We have 6.203, is it? 8 years. 6.203. We have 6.210. I think the question, it must be 8050, guys. Let me double check. It is 8.50. Yeah, it must be 8050, not 8060, 8050. So the answer we get is for the cumulative factor, it is 6.211. 6.211 in 8 years row. Check where we have it. 6.210 is there, right? Very close. 6.211 and 210. Only a small difference. 0.001 is the difference. That is for 6% we have that answer. 8 years, 6% is where you have 6.210. Then we can say the IRR should be 6%. Just double think, if it is 6%, cumulative factor is 6.211. So 8050 into 6.211 minus 50,000 will be 0. Double check. 8050 into 6.210 is what we had there, minus 50,000. That's almost 0, right? 10 compared to the thousands, 10 is almost 0. Yeah. So 6% is the IRR. The question was to find the answer to the nearest whole number. So even if you have got like 5.8, 5.9, now 6.1, whatever, when they say closest whole number, 6% is okay. Understand? Whoever is worried that there's a small difference between the final answer and this answer, don't worry. They are asking at the closest whole number. What you should have entered here is just 6 only. To the nearest whole number, they said 6. Just type 6 in the space. That should be the right answer. Here, what did we see here? When you get a constant cash flow every year, how to find PV? Right? One more thing I'll tell you, like this is what you call, guys, annuity. Annuity means constant cash flow starting from year 1. Annuity, let me give the features. Constant cash flow starting from year 1, no break, stops after a certain number of years. That's what you call annuity. That's what you call annuity. If it is, there is another case, look at this one. Year 0 and then forever. Like every year, year 1, 2, 3, 4, 5. Likewise, it continues. How much, let's say, cash flow you invested, let's say 10,000. Every year you get 3,000, 3,000, 3,000, not 30,000. It continues forever. It doesn't finish. It doesn't finish. It continues forever. It continues forever. So if this is the case, we call it perpetuity. See the difference. Let me show you the difference. Annuity and perpetuity, what's the difference? Just know these terms is good. Perpetuity. Perpetuity, constant cash flow starting from year 1, no break, doesn't stop. Or there is uncertainty about the lifetime. To tell you an example, some government jobs, they have pension scheme. Pension means as long as you are alive, you can get the pension. So how long a person is going to alive? Let's say at the age of 55 you retire and you apply for pension. At the age of 55, government starts giving you the pension. Every month they give you a fixed amount. How long they have to give it? As long as you are alive. How long will you be alive? 70, 80, 90, 100? No idea, right? So we assume the payment continues forever. That is because since there is an uncertainty about the period. So if that is the case, how do you find the present value? Look at this. PV of perpetuity is equal to the annual cash flow divided by R. So suppose in this case, if R is let's say 15 percentage, right? Let's change this to say 12,000, right? So PV of this perpetuity will be, look at this, equal annual cash flow 3,000 divided by R 15 percentage 0.15, 3,000 divided by 0.15. This will be the present value of all these perpetuities. All of them together. All of them together. Right. There will be infinite number of payments, right? Forever means. But all of them together, present value will be 20,000 only. So NPV of this investment has to be present value of future cash flows 20,000, initial investment 12,000. 8,000 will be the NPV of this, right? So these two are special cases of investment appraisal where you have an annuity or perpetuity, right? Have an idea how to handle questions with this. Thank you.